Hello everyone. Welcome to our another video in the series on mastering data structures and algorithms. I'm Dr. Prashant K. Gupta. In the last video, we talked about the sparse matrices and discussed the address calculation and some of the basic operations on the sparse matrices and different types of sparse matrices. With this, we have considered most of the operations on the arrays. Now let us begin with the linked list. This is a brief introduction about me. My website contains all the details about me, including my international visits, etc. Also, now I have started making available the PPTs for the lecture that I am delivering over here, as well as the links to the explanation videos and C programming codes for these topics. My passion is research and teaching. Now the idea is, why do we need linked lists? The arrays, they had the advantage of fast access. Given an index of particular element in the array, we could directly access that element because arrays are organized in contiguous memory locations. However, as we had seen, that it was difficult to insert or delete an item from an array. For example, given an array like this, if we had to insert an element at a particular position, say this, for insertion, we had to shift the element to all the successive locations and make space for the insertion of the element at this location. Further, if we had to delete an element from this location, we had to shift all the successive elements one by one to the successive locations. This is a difficult task and computationally inefficient also. If you haven't watched these videos on the arrays, insertion and deletion, I recommend you to do that. For example, why do we require the frequent addition and deletion of the items? Like see over here, an example of a shopping list. Such kind of lists or collection of items require frequent additions and deletions. Also, we saw that generally the size of the array is fixed. We cannot all of a sudden double or triple the size of an array because of the available memory allocation, and arrays are organized in contiguous memory allocations. By use of linked lists, these limitations can be overcome. Now the question comes, what are linked lists? A linked list is a linear data structure, which is a collection of elements called the nodes and linked together by means of pointers or links. We have different types of linked lists, one way, circular, or two way. Let's see how. This is an example of a one-way linked list, wherein, as I already told you, it is a collection of elements called the nodes and linked together by means of pointers or links. So nodes can be basically denoted like this. Every node has a collection of one information part and a link part, possibly except the start node, where the start node actually gives us the starting address of the first node in the linked list. Starting node is the only node that does not contain any information, only the address part. Except the start node, all other nodes contain the information part as well as the link part. The link part is a pointer to the next node in the list. Like you can see over here, these are the links. So similarly, we have all the collections. And when we reach the final node or the last node, that is identified by a null pointer. That is a link to no other further node in the list. There can be circular linked list also or two-way linked list also. There's an example of a circular linked list. Where the difference comes in, you have the start pointer, the information and link part in the other nodes, and then when you reach the last node, now you can see over here the address field is no longer null. The last node points to the first node. In a two-way linked list, we have a starting pointer or a start pointer and a last pointer called the end pointer. In between, the various nodes have pointers going in both these directions or links, you can see, except the first node that has a null pointer and only points to a node in the forward direction, and all other nodes intermediate to the linked list have a pointer to a node ahead in the linked list like this, and a pointer to a linked list back pointer to a node back into the linked list. And similarly, this goes on till we reach the last node, where you can see it doesn't point to any node further ahead because it's the last node. Now, a very important aspect of the linked list is that only the value of the start pointer is required to traverse through the entire linked list. And a special case may occur that we have just created a newly linked list or deleted all the elements of the linked list, and therefore the start value is null. That means it is an empty list. We'll see all these operations in details as we go through the linked list. So this is the basic idea of how to create a one-way linked list. Now this is a very important aspect. Creation involves declaring a start pointer and other nodes with two fields like information and link path. How do we declare the other nodes, or in general, all the start nodes or the other nodes are declared as the types of a particular node that we declare in the linked list? This is done with the help of these structures. And this is the basic C programming syntax of how to declare a structure. This is the keyword struct, and we have declared our structure name as node. Now our every node consists of an information part and a pointer or link to the next node in the linked list. And we are talking clearly about over here about the one-way linked list. We'll also come to the two-way linked list and circular linked list later on in the course. Right now, at the current stage for one-way linked list, we should follow this syntax. That is, it contains an information part which is of type int. We are free to declare information of other types also. And the struct node star link is the pointer declaration which will hold the address of the next node in the linked list. So this is an important aspect that the start pointer and other nodes are declared as data types of this struct or the structure. Now, what is the strength of the linked list? As we keep on growing and adding more and more nodes to the linked list, the size of the linked list will grow. However, in case of arrays, these data values that we had to store in the arrays had to be stored in the contiguous memory allocations. But in case of linked lists, this is the advantage that any two nodes need not occupy the adjacent memory allocations. And new node, whatever is added to the memory, it is allocated the memory dynamically using the malloc function. So let us have a very small look at a very small program. Now, this is the idea of creating a linked list and adding first node to it. Now, as we have already seen, these are the header files, and this is the header file stdlib.h that is required for using the malloc function that will be required for growing our linked list. Some compilers also support files like malloc.h. You are free to use that also. This declaration of the structure we have already seen. Now this is for the node declaration. Now how we declare the node variables? Because in itself, struct node is kind of a skeleton or a dummy. It doesn't contain any value till the time we declare a types of this struct and assign values to it. So this is done using this type of declaration. That is struct node, star new, and star start. Star means these are the pointers of the type of the struct node. Start will be the pointer that will be required to hold the address of the first node. And every time we'll be adding a new node to the linked list, we make use of the new pointer. This is a kind of variable. Now we have declared a type of the int data, and now the step comes where we want to add a node to the linked list. So this is done using the dynamic memory allocation. The syntax goes new equals to struct node star malloc size of struct node. The malloc function allocates the memory dynamically of the size of equal to a struct node over here and converts it to the type of a struct node star. Then we prompt the user to enter the value to insert and get it input from the scanf data. Now since our linked list is empty, therefore first of all we assign the values to this newly created node over here using these two assignment statements. That is, new info gets the value of data and new link becomes null. Null means because it's the first node that is entered and possibly the last one also. And therefore, finally, we assign the address to the start node of this newly created node. Thank you all for watching this video, and don't forget to subscribe to our channel for more and more good videos that will be coming up soon. Thank you.